All right, our last section here is on volcanoes, 22.6. Again, this is all being tied back to plate tectonics, our Earth's surface, the currents that are moving under the Earth's surface and forming dynamic changes on the surface that we are witness to. Okay? Basically, you know that a volcano, it is a mountain that forms when magma reaches the surface. So magma that is coming up through the surface is coming up from the mantle area, that liquid rock, and it's being pushed up because of different reasons and forming a mountain, and then it could actually, if the pressure is great enough, actually explode. All right? Very, very powerful natural phenomena. So under certain conditions, has to be a lot of pressure, small amounts of mantle rock can melt, forming liquid magma, and that magma rises upward through the crust, erupting at the surface as a volcano. So it's going to do it slowly, and it's going to build pressure over time until the point where the pressure is too great that it actually has to give way and be released. Okay? That's what this whole thing, this section talks about, the pressure that is building up. The magma approaches the surface. You have gases and increase in pressure, okay, expansion, and as a result, you end up getting an eruption. So we have different parts of the volcano. Just be aware of these. You've got this section here, the main vent here, that is your area where the magma is going to escape. So you've got this whole area there where the magma is starting to develop and build up. That's your magma chamber. The vent is the main opening at the top, okay? Or the crater here is what is created after maybe the top of the volcano is blown off. Lava is what is called, what you call it when the magma actually comes out and is on the surface now. So just be aware of these different areas and different parts of the volcano. The explosion can be quite powerful. Volcanoes erupt explosively or quietly. Now, you may not have heard of a quiet volcano, but it can just kind of seep out if the conditions are right. So it depends on the characteristics of the magma. Also, you should know that magma can vary in its viscosity, meaning how it flows. It can flow very slowly or more quickly, depending on what it's made up of. Okay? There are three main factors that determine the viscosity of the magma. Viscosity, again, is how it flows. If it flows slowly, it has a high viscosity. So temperature, higher the temperature, the faster it's going to flow. Water content, the more water, the faster it's going to flow, and silica content. All right? If it has a lot of silica, it's going to have a slower flow. So let's just rewind here and review that. Higher temperatures, it's going to have a faster flow, a lower viscosity. It flows more easily. If it has more water in it, it'll also flow more easily, have a lower viscosity. But if you add something to it like silica, it's going to slow it down, it's going to have a higher viscosity and slow down the flow. Okay? Quiet eruptions. You may have never heard of quiet eruptions. It's not well publicized, but volcanoes that have very hot, low silica magma, they generally erupt quietly. So what that means is they flow out, the magma flows out very easily and flows quickly, and not a lot of pressure is built up. Okay? You basically have a stream of fast flowing lava, a lava flow. Explosive eruptions happen because you've got a lot of maybe silica in there, and it's going to move slowly, and pressure is building up quite tremendously. And as a result, when it does explode, it's going to do it explosively. Okay? This map, we've looked at this before, and this basically is areas. You can see where a lot of volcanoes are, the red triangles, and they happen along these boundaries, as we've talked about before. So along the boundary areas, and you'll notice that many of the boundary areas where there are volcanoes happen where there are convergent boundaries. So you have the plates moving away from each other, and as a result, the magma is going to be coming up through that area where the plates are moving away from each other. Okay? Most volcanoes occur along plate boundaries. They call them hotspots. Okay? They often form along a converging plate boundary. Oh, I'm sorry, I said divergent. Oh yeah, convergent. I'm sorry, convergent. Here you go. Convergent. Oh, I'm sorry, but I said it's because they're moving away from each other. I should have said they're moving towards each other. I apologize. Convergent, they're moving towards each other, and as a result, what happens is the rock is getting pushed down and is turning into liquid rock, and so that's going to cause then the possible volcano to form there. Okay, so let me get this right again. Volcanoes form along converging plate boundaries where oceanic plates are subducted, meaning they're going below, the plate is going below the crust, and then this is turning into magma, and that magma then could then form a volcano. Okay? Magma forms and rises to the surface. So many volcanoes have formed along the trenches that rim the Pacific Ocean. We mentioned that is called the Ring of Fire. Okay? The three major types of volcanoes are shield volcanoes, cinder cones, and composite volcanoes. You just need to understand the names just describe a little bit about them. All right? A quiet eruption or low viscosity lava produces a wide, flat volcano. Shield makes sense. Okay? An eruption is entirely ash and cinder. The result will be a small, steep-sided volcano, cinder volcano, a cinder cone volcano. And if it's explosive, you've got a combination of lava and ash, you're going to have a composite volcano. All right? And there you've got a shield volcano, composite volcano, and a cinder cone. These would be igneous rocks, different types of rocks that are formed from magma cooling. Okay? And I'm not going to be asking you about any of these things, so you don't have to worry about these other igneous features. All right? That's it. That's volcanoes. Straightforward, simple. I think you guys will do very well in this chapter, and if you got questions, let me know.